right, welcome back. Uh, Last time we went through SAT Module 1 and 2 for reading on SAT Test 5. We did the hard Module 2, of course, because it was my first time going through it. I always try it authentically. For those who did watch, you'll remember that I ended up missing 3 questions in Module 2. 2 vocabulary questions and 1 inference question I was kind of torn on. I encourage you guys to go watch that if you want to see what's new. We've got the test 5 loaded up again. We're going to go ahead and skip the reading, and we're going to do just the math sections today. So in order to do that effectively, let me make sure that my screen size is correct here. Go ahead and hide myself down there. I'm going to make my whiteboard a little bigger because we're going to need the math today. So let's go ahead and dive right in. I guess I can put my camera down below. Doesn't have to be beautiful. Nobody really cares. All right. There we go. So we're just going to skip right past the reading because we already saw that. And I'm not going to do reading module 2, the easy version of it. I am curious about how that looks, though. They did, oh, that's a nice feature. They made it so that you can't accidentally skip past questions, so that's pretty neat. Can't accidentally submit for double clicking, which is nice. All right, we're going to go ahead and resume testing, and now we're going to take it for real. Again, make this slightly bigger so you guys can read it, and move it over slightly so you can see what I do on the whiteboard. Okay, first question. It's a linear function, just looking at the answers. We've got different slopes, so that's all I'm going to pay attention to, and a y-intercept. So 25 calories per pound, it's going to be D, because we have an 11 calories, which represents this. Okay. So that was y-intercept and slope. Here we have different descending numbers. We're making a conversion, fathom to feet. So no craziness. 39 fathoms is how many feet? So 39 fathoms and is times 6 feet per fathom, 1 fathom. I realize here you can't see what I'm doing on the whiteboard. Let's see why that is. Move that over. Huh. I'm going to go ahead and there we go. Now you can see it. 39 fathoms times 6 feet per fathom, so that's 39 times 6, which is going to be 180 plus 54. So that's going to be 234. Don't even have to do the addition because that's the only one that's close. All right, we have our first geometry thing. It's lines and triangles category. Which the following statements is true. That's all there is to it. Okay, so x is 145. Equal to 145. It's vertical angles. Linear function again. How many games can be played for total cost of 58? So f is the cost, so that's 58 equals 14 plus 4x. 58 equals 14 plus 4x. Subtract that over, we get 44. 4x dividing by 4 is 11. Okay. Let's see, we got a linear function again. What is the value of x minus 7? You'll notice that 4x minus 28 is exactly 4 times that. So dividing by 4, we get negative 6. The amount of Hannah's bill for food was $50. Tip of 20%, so that's 1.2 times the total. What was the amount of the tip Hannah gave? Oh, okay. So we just want 20% of 50, which is 1/5, so $10. I'm going to double check myself because I don't trust myself. I'm going to do it in a calculator off to the side here. 0.2 times 50 is indeed 10. I never trust myself on these types of things, and it's too important to get it right, so take that extra beat to check your math. All right, we've got a bunch of extra detail up here I'm not going to bother reading. 121 eggs is added to create a new data set. So we're adding a sixth row to this. It's less than all the rest. Which of the following correctly compares the mean of the two? The new data set will drag it down because that's less than all the rest. So the original is greater than the new. Less than, equal, not enough. Nah, we have enough. Linear inequality this time. We could graph each of these in Desmos, but we might as well just know what we're doing here. It's a negative slope, so that gets rid of A. I'll go ahead and turn on this. That gets rid of A and C because those have positive slopes. Just because it's an inequality doesn't mean that the behavior of the graph changes. It has a positive y-intercept. Ooh, I don't love that. Oh no, it has a negative y-intercept. Got to look at the graph a little more carefully there. I was thinking this was the y-axis. It's actually the solid line over there. So it is -1. And y is greater than because it's shaded above. Combining like terms is non-equivalent or non-linear equivalence. For those who are looking for things in the question bank, you got to remember to distribute the negative. So that's going to be 8 minus -2 is going to give us 10 there. Linear function, we've got the y-intercept is 9, so right away that's going to get rid of those. We've got a slope that goes up 8 over 1, so that is, you got to remember rise over run. A is a decoy because it flips it. Quadratic, solution to the given equation, you just add the 7 over that goes away, and this becomes 30 or -30. Both should be acceptable. Linear function in standard form. What is the price of each small? So it's either 5.4 or 4.51 or 6.07, depending on which one is small. A reasonable guess would be the x. X is the number of small. So, yep, price for each is 4.51. No math to be done. Exponential function. This will be a nonlinear algebra in the question bank. Coordinate the model, which is the estimated number of particles in the X-ray beam when it's at the surface of the sample of iron. Okay, so I'm thinking that's going to be the y-intercept. Number of particle t millimeters below the surface. So if it's at the surface, t is 0. So it's 500. If you put 0 in, you get 0.5 to the 0 is 1, 500 times 1. Or you can just memorize the y-intercept as the leading term. Graph the function shown, f of x, and x is greater than 0, which of the following is the graph of this function shifted up 5. So I'm going to pick a point. I'm going to pick, we got 1, 9 here. So this should become 1, 14. Ooh, okay, that one's promising. Both C and D could be it. These both shifted down. Get rid of those. I'm going to pick another point. We're going to go to 9, 1. Should become 9, 6. So that's 9. Nope. Get rid of that. And there's our guy, 9, 6. This sometime, like, how much math have I actually done? Now we're already on question 15. All right. We've got a nonlinear equivalent again. I call these rearrangers. You don't even have to read any of this. Just look at the answers and you see we're solving for C. P divided by N is our first move. And then we're going to subtract 19, but then this negative is going to flip the sign and everything. I'm going to go ahead and do this on the whiteboard. Just show you what I do here. So we got P equals N. I noticed that I don't actually have to stack my things. You guys see what I'm doing no matter what my screen arrangement is. I'm going to make this a little bit more comfortable for me. All right. All P equals n 19 minus c. Divide the n, we get p over n equals 19 minus c. Subtract the 19, p over n minus 19 equals negative c. Flip the signs on everything. We got negative p over n plus 19 equals c. We're of course going to have to switch the positions on those because all of our answers have the 19 first. So that's going to be minus. So 19 minus p over n. Okay. We have our first geometry question. It's a square exterior surface area of this box without a lid. So we're going to take the surface area of one side and multiply it by 5 because a cube has 6 faces and the lid is not present here. So 29 squared times 5 is what we're going to do. So into the calculator, 29 times 29 times 5 is 4205. Absolute value, fun little guy there. Going to go ahead and get our calculation here. They want the sum of the solutions to the given equation. I'm sure there's a shortcut to that. I just don't know it off the top of my head. So I'm just going to do the math. X minus 9, absolute value. Subtract the 45. That's going to be what? People, of course, are faster than me at that. I think that's 18. 10 is 55 plus 8 more. Yeah. So absolute value, you have one expression that's the same, and then you have another expression where you change the sign on the right-hand side. This, of course, will give us x equals 27. This will give us x equals negative 9. The sum of those two things is 18. I wonder if the sum of the solutions is always the difference between these values, or what's equal there. Equal on this step. I wonder if that will always be the sum of solutions. We can do a quick proof at the end of the video. And again, I see, yeah, I have to be mindful of what you guys can see in the whiteboard there. All right, just one more check on my math, and we have enough time. We've got 24 minutes left and only 5 questions left to do. It took me, what, 10 minutes to get this far? Anyhow, so double checking our work, we subtract the 45, we add the 9 to get 27. We add the 9 again to negative 18 and get negative 9. 27 plus negative 9 is indeed 18, so the sum of solutions should be 18. What's the value of tangent? 92 pi over 3. Okay. Some unit circle stuff getting thrown in here. I'm going to go ahead and squish that over, get some more room here. So tangent of 92 pi over 3. So what do I want to do here? It's multiple choice. I'm going to go ahead and go back here and mark that one for review, just so I don't forget to do the proof. I notice my answer choices all have this root 3 in it, so they're probably telling us that this is a 30, 60, 90 right triangle, because that's the only way you're going to get a root 3 out of this. But I don't necessarily want to use 30, 60, 90 ratios on this until I know what I'm doing. So pause and think. So it's 2 pi for an entire circle. So let's go ahead and do this division real quick and reduce this. 92 divided by 3 is going to be 30 with a remainder of 2/3. So you're going all the way around 15 times, because we got 30 pi and 2/3 plus 2/3 pi, basically. So we can ignore this. 2 pi over 3, that's really the important bit that we got. So that lands us over in the second quadrant, if I remember my trig. It's been a little while since I've had to do that, and that indeed should be a 60-degree angle from the reference. So the tangent of that should be root 3 over here and -1. So negative root 3 is my answer. That's coterminal angles. You learn that in pre-calc in most high schools. Okay, we've got another rearranger here. I hope you guys can see that well enough. I'm going to see if I can make that bigger. Yeah, checking the stream, it looks like you guys can see that reasonably well. Okay. So another rearranger. K is greater than this expression is equivalent. These are crazy looking things here. So I'm looking to see if I can make it bigger for me because on my screen, oh, there we go. That's how I do it. Just like a web page. Okay. It's pretty small on my screen still. I'm just old. So the first thing I notice is that all of our answer choices have one denominator. So that means we're going to get common denominators. Whenever you're adding fractions, you have to have common denominators. So that's the first step. Let's go ahead and get our whiteboard oriented here. So we've got 42 a over k plus 42 ak. To get common denominator on that, we're going to make that squared, multiply k on top and bottom. We add them together. We get 42a plus 42ak squared all over k. Can't reduce the k because of the addition, but we can factor the numerator. So we're going to get what are we going to get here? We're going to get 42a times 1 plus k squared over k. Let's see if that's an answer. 1 plus k squared. Yep, we got it right there. All right, looking again. This is a circle expression now. What are they asking? They want the point AB is on the circle. What is the possible value for A? So we want the x coordinate of a term that is on this circle. Interesting. We could probably graph. I don't know if Desmos likes graphing circles, but we do have the Desmos calculator available to us here. I'm not going to use that. I'm not going to use that. Maybe a little smaller. There. I think you guys can see that. There we go. So the center of the circle is at -419, and the radius of the circle is 11. R equals 11. So what we can do here is we can just do the obvious thing and check like the furthest boundaries for each x coordinate. So naturally, if we went out horizontally from that point, -4 plus 11 is 8, -4 minus 11 is -15. So our x-coordinate has to be between -15 and 8. And the only one that fits that bill is B. So that's kind of the lazy way to do that. That's the intuitive way that came to my mind instead of trying to graph and do plug and check and all that. Just find the maximums and minimums. You got to think like an engineer on this stuff. Okay, we have expressions as our answers again. These are all cubic, except, okay, first two are cubic, bottom two are quadratic. What are we looking for? We want the volume, so that's always going to be in cubic, unless one of these is defined in a different way. So just knowing that our units should be cubed for volume helps me get 50-50 on this without even doing any math. And I just read the last line there, which function v gives the volume of the prism in terms of the length of the prism's base, which I assume is x. Yep. Height is 9. The length of the base is x, which is 7 more than the width. Okay. Okay, that's why we have to actually read, because 9 represents one of our axes here, so we're not going to have x in the vertical dimension. X will only be represented in the length and the width. And x is, the wording here matters, whether it's x plus 7 or x minus. X is 7 more than width. X is 7 more than the width. So if that's the case, x is 7 more than the width of the base. So x equals 7 plus w. That means w equals x minus 7. So if I want to get the volume of this thing, it's the length times width times height. So x times 9, length, times sorry, just fighting with my stylus here. Length times width times height. The height is 9. The width is x minus 7, which we just solved for. So obviously it's going to be d. Okay. Next one, function f is defined by this stuff. A and b are constants. So many people that I work with get hung up on the fact that they say a and b are constants. That just means that they're a number. It doesn't mean anything significant here. It just means they're a number, a specific number. And we might need to find out what those numbers are, but we don't particularly care right now. XY plane, the y equals f of x passes through the point there, and f of 24 is less than 0. Okay, fine. So the first thing I like to think about is, what is the parent function doing here? So a regular square root function is going to look something like this. A, the coefficient A, is going to be the vertical stretch. It's going to determine kind of the squishiness in that vertical direction. B is going to be like left-right shift, because it's with the x underneath the square root. If it had like a plus c on the outside, it's going to be a vertical shift, but we don't have that here. So we know this starts at the origin, 0, 0. And they give us that negative 24 gets us 0. So they're basically telling us that this has been shifted left 24 units. So B is 24. And f of 24 is less than 0. So they're telling us that A is negative. So let's do that in Desmos. I'll demonstrate that. So in Desmos, what we can do is we can plug that exactly. And if you don't know the shortcut, it's just SQRT for square root. X plus B. You create sliders for each of those things. Let me go ahead and show what happened here. So we plugged that in. We created sliders A and B. And as B increases, or A increases, that gives us that stretch. But if it's negative, it goes underneath. And if B increases in value, it goes to the left. If it decreases and gets negative, it goes to the right. So if they're telling us that negative 24, 0 is on the y-axis or the x-axis there, that means B is negative 24, and that means that A is negative. It must be negative. F of 24 is less than 0. Which one must be true? F of 0 equal, it can't possibly be equal to positive. It is possible that A is greater than B. Or no. Sorry, B is positive 24. A is negative, so I don't know why I'm overthinking this. A negative is obviously less than a positive. B is positive 24, and A is any negative number that you like, so A is less than B. And that's that for that. That's module 1 in the bank. Obviously, I wasn't going as fast as I possibly could there, but I didn't need to. So I'm going to try to go a little faster here at the beginning because I know these ending questions are going to give me some trouble. They always do in these modules. So right triangle has lengths of 11 and 9, length triangle hypotenuse. So this is Pythagorean theorem. 11 squared is 121, 80 plus 81. 121 plus 81 is 202. You take the square root of that. Oh, they just give that as an answer option. We got a linear function again. Slope goes up 4 over 2, so slope is 2. Didn't need to solve anything else because all the answer choices were different. I'll show that again. All the answer choices are different, so just find the slope and move on with your life. Okay, we're looking for an interpretation here. Stocks and are defective. Random sample 310 produced in a certain week are inspected. Based on the sample, 12% of all stocks in this week are defective. That's a lot, with an associated margin of error of 3.62. Okay, so anywhere from as low as 8 point something up to 15.62 is going to be defective, based on the estimate of the margin of error. Which of the following is most appropriate conclusion about the stocks company during this week? So that's not correct interpretation there. Yeah, that's probably the best answer. No, no. They're just testing us on our understanding of margin of error on that question. Linear inequality again in standard form. We need to just find out whether it's less than or greater than and which one the 25 goes with. So maximum, so it's going to be less than. 25 and 62. 25 goes with X. I don't care about any of the details on those. Just scan for what you need. Could plug in these answer choices and see which one the solution is, but they do give us this nice ratio here. And there's a old question in a paper format that did something like this, and the solution was you just get the ratio of X to Y. On this one, it's going to be 2 over 5 because you just kind of divide the terms back and forth. So if I put X over Y, I should get 2 over 5, and that's the one that does that. The fact that it's a system doesn't really matter because it's a ratio. Okay, range. What is the range? That's minimum and maximum subtracted. So minimum, it does appear to be in order. So 23 is the min, 52. That should be easy subtraction. What is that? 19, 29? I can't do it. 52 minus 23 into the calculator, it's 29. Okay, I can trust myself still. Okay. All numbers, same kind of bread, exit store. The first customer is that for 1 loaf and 2. They're building a system for us. All right, we have 1 bread plus 2 eggs is equal to 12.45. 4 bread plus 1 dozen eggs equals 19.42. What's the cost of 1 dozen eggs? What's the cost of E? So we're going to look to multiply this one by 4 so that you guys can't see what I'm doing. I'm going to go ahead and drag that out of the way. So you construct your system of equations there. You'd multiply that out. 16b plus 4e equals 4 times 1942. 4 times 1942. You could do this in Desmos. Once you got your equations, you plug them in, find the intersection. It's actually a pretty straightforward process to do it by hand, however. And then we're going to subtract going up. So 7768 minus 1245. And the b's cancel out. We get 2e equals 6523. Divide that by 2, and a dozen eggs is... What? That doesn't seem right. $19 for 4 loaves and 1 dozen eggs? What country do they live in? So these that number does not seem plausible based on what I've got there. So I'm gonna double check. Oh, I counted that. I looked at that as a 16. That's a B. Start over. 1B plus 2E. Use capitals. Mind your handwriting. 1245. 4B plus 1E is 1942. We want the b's to cancel out, so I'm going to multiply that one by 4. My goodness. Okay, so we get 4b plus 8e equals what? Calculator 1245 times 4, 4980. Subtract 1942, we get 3038. So 7e equals 3038. Divided by 7 is 434. All right. Y equals 18, just plug it in. How many points does the graph of the equations intersect? You could solve this out by hand, but I'm just going to plug it into Desmos. So y equals 18, y equals negative 3x minus 18 squared plus 15. Zoom out. None. No points of intersection. Oh, another system with a quadratic. What is the greatest possible value of x? Again, I'm just going to plug that into Desmos. So just modify what I've got there. X plus 9. X squared plus 16x plus 63. What is the greatest possible value for x? Negative 6. Just graph it. Why not? Oh, could you guys see that? Yeah, you can see that. You can see that. Okay. Okay, this one's a bit nutty. Bring that over. Bring this back. Okay. P is the slope of negative 5/3, x-intercept of 6, negative 6, 0. What is the y-coordinate of the y-intercept? Okay. So we're going to use point slope form because that's what they've given us. It's the slope and a coordinate point. So we're going to use y minus 0 equals negative 5/3 x minus negative 6 becomes plus 6. Y equals mx plus b. Distribute that negative 5/3 through. Minus 30 over 3, which is 10. Negative 10 becomes our answer. Don't forget the negative. Just double check. Yeah, okay. How many solutions does that equation have? It's a linear function. The slopes are different, so 1. They don't care what the solution is. Just double check. Make sure no silliness is happening. 12x, negative 3x, different slopes, 1 solution. Okay, Caliani, who cares? It's a linear function. 5 yards for a suit for men's choir. Total length of the fabric she purchased, y yards, is represented by that. What's the best interpretation of 6 in this context? So 5 yards for each suit. So that's going to be x is each suit that's made. 5 is the number of yards. Number of suits, and the total length she purchased, y. So 6 is how much is left over. 6 more for yard fabric than she used. Yeah, because if X is the number of suits, 5X is the amount of yards she used, Y was how much she bought. So how much you buy minus how much you use, it leaves us with how much extra you got. So there you go. No real solutions. You could plug all of these into Desmos and find the one that does not touch the x-axis. I'm just going to use the discriminant on each one because their B and C values are the same, except for some plus minus shenanigans. Would it be better to do this in Desmos? Yeah, it's so fast in Desmos. Like, I'm just going to clear, Control Z on that. Don't forget about Control Z. So in Desmos, I'm going to type that first one, x squared plus 14x minus 49. The careful thing here is make sure you don't have any typos. So that one clearly has an intercept. I'm going to change that to the 5 version, doesn't make a difference. Change that to plus 49, and I think we might find it. Nope, that has one solution. So that's going to be, change that to a 5. Yep, there it goes. So 5 plus 14 plus 49. Oh, we don't have that option. Bring Desmos back. Look at it again. We got minus 14 for each of those. So minus plus 49 didn't work. Try minus 49. No. So it must be minus and plus with that. Huh. No real solutions. Which quadratic equation has no real solutions? Did I mess that up? Let's be a little bit more systematic in our approach here. So we got x plus 14 minus 49. That has solutions. Minus plus. I feel like I could have solved it by hand by now. 5 minus minus. I'm using all the right numbers, right? 5 minus minus has solutions. 5 minus plus. There it is. How did I miss that? Either way, that's the way to do it. Don't overthink this stuff. All right. We got an exponential function. Which of the following is the closest value of p? P is 84, isn't it? P over 100 to the x. Okay, rewritten. Oh, but they got rid of the denominator there. Okay, so I'm going to do this by hand, I think. So we got 1 plus 84 over 100 raised to the 1/4 x. Distribute that 1/4 through. You get 1 plus. So I don't like the plus there. We're going to keep that as 1.84 to the 1/4 to the x. So that's what I'm going to plug into my calculator. I'm not using the Desmos calculator for this. Just using my standard regular old calculator. Actually, I will use Desmos. My calculator doesn't do exponents nicely. 1.84 raised to the 0.25 power is 1.6 something there, 1.646. So closest value of p. I was looking for 64. That is a 4, right? Yeah. Get that Desmos calculator back here. 1.84 raised to the 1/4 power. We did 0.25. Let's see if Desmos treats this any differently. 646. Okay. 1.16. Ah, read it. Gotta read it. 16. Move on. Okay, we have a system of equations again. No solution. There's a value of p. These are all appear to be linear. No solution. Ooh. Okay, so you add that. Let's combine like terms. Just get things by themselves first. So 6 plus 7r equals pw. Okay. The other one only has r and w. So let's get it in the same form where r and w are on opposite sides like that. So I'm going to bring the constant to minus 11 plus 7r equals 10w. So it's 10. Yeah, you treat it like x and y. 7r 10w, yeah. Constants with a value of b times c. So they give us the vertex at -1, negative 8. So we know negative b over 2a gives us the x-coordinate of the vertex, which in this case is -1. So a is 2, so negative b over 4 equals -1. So that means b is 4. So b is 4. C gives us the y-intercept, which is -6. -6 times 4 is -24. I might come back and check that one if I have time, which we probably will. I'm making really good time on this. This is the fastest I've been on a module in a long time. I'm a little worried by that. Linear functions. Function is shifted up 19 units. C and D are positive constants, which one could define f. C and D are positive constants, so it's a negative slope, so that means we have to have a minus C if C is positive. It's shifted up 19 units, so D needs to be positive. So that's going to be our guy, I'm pretty sure. It's a ratio question. Whenever you have a triangle nested inside of another triangle, you're doing ratios. What's the area of triangle ADE, the big one? Okay, so I usually like to draw these again. AB is root 34, and label what I know. So this is root 34. AC is 3. CE is 21, so that means this whole thing on the big triangle is 24. Cool. So we have a ratio of times 8. So this whole thing is 8 root 34. Which I don't think is reducible. No, that's 17 times 2, that's prime. Okay, what is the area of that triangle? So we're going to use the Pythagorean theorem, I think. Yeah. So knowing our side lengths, 24 squared plus x squared equals 8 root 34 squared. Plugging this into the calculator. 24 times 24 is 576. Plus x squared equals 64 times 34, basically. 2176. Subtract that over and square root it. It's 1600, and the square root of 1600, I believe, is 40. Yep. And they want the area, so 1/2 base height. So the base was 24. The height we just solved is 40. I'm sure that's a Pythagorean triple, but I don't happen to recognize it right away. Doesn't seem to ring any bells with that root 34 in there. So 1/2 times the base times the height, that's 20 times 24, which some people may be able to do in their heads, but not me. Not right now anyway. Is 480. Hooray. We're doing on time. Quick clock check. Increasing quantity of X by 400% is 60. Okay, so just checking to see if we understand percents. So 400% of X increasing by 400%. So X times 1 plus 4 basically equals 60. So 5X equals 60. Because remember, A times 1 plus or minus R over 100 is our function here. And if it's 400%, we've got 1 plus 400 over 100. So that's why I'm doing 1 plus 4 here, and X was our original value. So X equals 60 divided by 5, which is, what is that, 12. Okay, it tells us there's a circle. A and B lie on the circle. A has coordinates there. And ACB is a right angle. Wow, this is what I was talking about. These ending questions are beasts. Okay, so we got a circle. HK is the center. There's a point H plus 1K plus root 102. H plus 1K plus root 102. We can understand that to be a right triangle with the radius there. So the distance on the horizontal is 1. The distance on the vertical is 102. Root 102. So we can do the Pythagorean theorem and find the radius. ACB, A and B lie on the circle. ACB. Wait. I don't see how that plays in here. I need to envision this. So point A has these coordinates. So A is here. B is off this way somewhere. And it makes a right triangle. That's what they tell us. So that's B there. This is 90 at the origin. That's 90. Okay. I've lost my cursor. There it is. Okay. So we've got a 90-degree triangle. A is off that way. B is off that way. We want to find this distance right here. I can find the base right here really easy by using the Pythagorean theorem on that. 1 root 102. And that's the radius, so these should be the same. It's a 40, okay, that's a 45, 45, 90 because those bases are both radii. So as soon as I find the radius, I can multiply it by root 2 and get the answer. Okay, now that we've got a roadmap, let's go ahead and get to work. We got to do the Pythagorean theorem to find the length of that radius. So 1 squared plus root 102 squared, of course, is 102 equals the radius squared. So 1 plus 102 equals radius squared. So that's 103. The radius is the square root of 103. Okay. Times root 2 is going to give us the length of AB. So that's square root 206, I guess. That's kind of weird. Yeah, okay, that's actually an answer. Huh. I don't know about that. I'm going to come back to that one and see if they have any recommendations on how to solve that better. I doubt it. Okay, we got a big old word problem here. Jump to the end. What is the flux volts times meters of the electric field through the larger square? Oh, shoot. This is like a legit physics question. All right. Electric field, don't worry about that kind of stuff. They're going to give you enough to answer it. As you've seen, the earlier questions were easier so that we can do big crunchers like that. I'm actually going to do 22 first because it looks easier. And I'm going to come back to that one. Okay. Where's the following could be an equation of line of best fit for the data set F. We see a y-intercept at about 12. So that's going to lead me towards these two. These are all linear functions y equals mx plus b form. So I'm thinking 12 is our y-intercept. And I estimated that because I knew this was 15, and that's about halfway. I got lucky, I guess. And then the slope, 5.9 or 1.5. So let's just pick a point here. That's 2, and it goes up. It didn't go up 5, going 2 over. So the slope can't possibly be close to 6. We would expect go 2 over, you go up 12. So no, that has to be closer to 1.5. Goes over 2, and times 1.5 would be 3. And it approximately did. They went 15 to approximately 18 or 19. So that's that. All right, come back to this monstrous looking thing. It may look big and scary, but I wonder how the math on this is going to work out. I bet that circle question is the hardest one on this set. Okay. Electric flux, whatever. Okay, product of the electric field strength and the area of the surface. So they just gave us what to do here. We're going to take the product of the surface area times its field strength. Two adjacent squares, side length in meters is 3 times the side length of the smaller. So we have 2 squares, x and 3x. Okay. An electric field with strength 29 passes uniformly through this surface, which is perpendicular to the field, so 29 times these areas. If the total electric flux through the surface is that, so 2 adjacent squares. Okay. So they're giving us the result, 46, 40 equals 29 times the area of the first, 9x squared, plus the area of the second, x squared. So that's 10x squared. 29 times 10x squared equals 4640. What is the electric flux in volts times meters? In voltmeters. I don't think the unit of measure matters on this one. So let's go ahead and just do the algebra on that. So 29 times 10 is, of course, 290 x squared, 4640. Trusty calculator, 4640 divided by 290, which is 16. Square root of that is 4. That's not what we want, though. That's x. That's the side length of the squares. If the total electric flux of the field through this, what is the flux through the large square? Oh, interesting. Okay. So how much of that 4640 passes through this large square? So if x is 4, then the side lengths are 12 each. So that's a total area of 144 times the 29 field strength. And that gives us, I'm just going to double check my math there, 12 times 12 is 144 times 29 is 4176. And I'm again just going to double check to make sure that 4176 is 3 times as much as what goes through the other one. So 4640 minus this. Times 3. No, we times 3 again. Yeah, so it is indeed 3 times per unit area of the field. So I, knowing how to do that, double checked my work and made sure of it. I've got 5 minutes to spare. So I could double check my work, but I'm curious. So let's go ahead and finish there. Next, module is over. All right. That was that on test 5. Nothing too crazy. There were a couple that were hard, but I don't think anything would be out of scope or reach with what the previous tests were expecting. I do wonder what kids would feel on that. So let's go ahead and pull up our score report page. I'm going to sign in again. Make it so you guys can't see that process. Don't want you seeing all my browser info. So practice test 5. All right, pull this up. There we go. Oop, that's not what you want. There we go. That's the one. So you'll see the 960, the 760 on the reading and writing, 780 on the math. I did end up missing 1 or 2 questions. Let's go ahead and see which ones those were. Skipped all the reading, of course. Got all the module 1 correct. And I missed 2 questions in module 2, the linear function right at the end. I knew it felt too easy. We did get the flux one right. Let's go ahead and take a look at this one. Ended up missing 2 of the linear function questions. Let's dig into that and see why. All right, so we'll hide the correct answer and explanation. Graph of the linear function is shown. C and D are positive numbers. That's all the word constant means. Make this bigger so you guys can see it again. So if they're positive, we know the slope needs to be negative. So we need to have a minus cx, so it's either A or B. I said it had to be B because we knew that the y-intercept has to be positive because it's plus 19. So why is it not B? A is correct. C and D are positive. It's shifted up 19. Why is minus D what we're going to do? Oh, crud. Plus 19 is shown. Read the question, chat. If this is the shown version that's shifted up 19, then of course this is at a y-intercept of 3. So D is going to be a positive number, but the y-intercept is negative, so of course it's A. Gotta read the darn stimulus. Let's read this. F is created by multiplying y coordinate of each data point from E. E is, oh my God, did I do it again? I didn't read the stimulus. I didn't read the stimulus. XY for data set E. Data set E is formed by multiplying the data set F by 3.9. What could be the line of best fit for data set F? So you take all this stuff and you multiply by 3.9. So the answer should be B. The slope will not change, but the y-intercept will be approximately 4 times bigger because 3.9 is almost 4, so it must be B. A? Will the slope change too? Oh, the slope would change because this point goes up by 4 times, so it's like 15 times 4 is about 45. But then this point also goes up by approximately a factor of 4, so 30, let's call it 33 times 4 is going to go all the way up to 120 something, 152. So the slope and the y-intercept would increase, of course. Yeah. Uh, okay. Yeah, and that's exactly what the error says. Read the stimulus. All right, let's take a look at this. 16 times over x area. Yeah, you find the area, multiply it by the strength, and that gives you your thing. That's exactly what we did. Okay, let's go back to the other one that I flagged. Does it show that you flagged them? No, it doesn't. Well, that's not very useful. If I flag something for review, it should show me which one I flagged for review. uh, which one was that? It was this one. Yeah. Um, sum of the solutions to the given equation. So I wanted to see if there was a way to generalize that idea. So it's an absolute value. Um, so let's go ahead and hide that from the view. Get rid of that. All right, we're just going to look at a whiteboard. Okay, so the expression that we were given is x minus 9 absolute value plus 45 equals 63. If we subtract that over, of course, we get our 18. X minus 9 absolute value equals 18. I wanted to see if there was a way to generalize this idea, this concept of sum of solutions for an absolute value. We can do that with the quadratic because you take the sum of solutions, you just get negative b over a. I want to see if we can do something similar for absolute values. So I'm going to say x minus h equals k. X minus h equals k and negative k. So that's the solution. So the solution for this first one becomes x equals k plus h. And the other solution is negative k plus h again. You add those two terms together and you get h. So, or you get 2h rather. So the sum of solutions is 2 times the opposite of that number. So sum of solutions in absolute value is equal to 2h in the expression x minus h absolute value equals k. Cool. Yeah, mathematicians always like to generalize and find some sort of shortcut to things, and I think that's a pretty elegant one. Thanks for hanging out with me and going through Test 5, Math, Modules 1 and 2, of course the hard version of Module 2 on this run. Hopefully you learned something, hopefully you found something very useful, and it made the SAT Math a little less daunting, a little less mystifying. Thanks for watching. Have a great night, guys.